So the strength of HSS really comes down to its shape. So it's a closed shape, which means that when people have thought of HSS in the past or been exposed to it, it usually was in resisting torsion, because closed shape is always going to be more resistant to twisting loads or torsional loads. But that shape also leads itself to other strong applications. One of them that I think is underutilized is in the column application, especially long, tall columns where you have a long unbraced length. That closed nature allows you to have better performance using the same amount or less area because of the closed nature of that shape. So that's where we think that people need to consider using more HSS is in the column applications where you have long unbraced lengths.
You know, the ability to save weight is probably far and away the most significant thing, but there are definitely other benefits. I mean, obviously, I think the situation where a lot of engineers run into HSS use is with aesthetic applications. Certainly just a cleaner look having a closed square or rectangle compared to a wide flange shape. Even though that's a great application for it, there's certainly a lot of more technical benefits, but also things that are easy to overlook, such as, for example, having a smaller surface area means that whether it's cementitious fireproofing or paint, you're going to require less coating.
One of the things that we get fed back to us from other engineers is, when they say, "Oh, we love HSS because I can hide it in a wall," because they're able to design it in such a way that it fits in with partitions, it fits in with the architect's desire to maximize the space. And so that's one area that we do get positive feedback about the use of HSS is it has a smaller footprint, therefore it's going to not take up as much space in the building.
If you're looking at a building, the big factor that's going to determine whether HSS is right for that application is basically how slender the columns are, so your KL over R. If you have a very tall column, if it's very heavily loaded, then that's still probably going to be relatively slender because of its height. And in those situations, a jumbo HSS can potentially save a lot of weight over a traditional wide flange shape. But it's not just in those kind of heavy and tall applications. If you have a smaller building, say a 5-story office building or something like that, where the story heights are smaller, but the weights are also smaller, then there's a potential to save weight there as well. So instead of looking at maybe a 20-inch HSS versus W14 by 370, maybe you're looking at an 8-inch square HSS versus a W12 column, but the engineering mechanics that go behind it are the same. Anytime you're somewhat slender, you're going to see those benefits. And so length to load ratio is not really a scientific quantity, but I think it's a good description, a good concept to keep in mind when you're choosing your materials.
So HSS is structural steel, and so we want to make sure that people consider that as part of the tool in the toolbox. Because when we're designing with structural steel, we want to make sure that we continue to design as efficiently as possible. And so I like to say to engineers, it's like, if you don't use all the tools in the toolbox, you're not really doing your job as efficiently as you should. So HSS is one of those tools that maybe gets left in the toolbox a little too much. And so by looking at the total efficiency of a structure and taking advantage of the strengths of HSS, we can bring a whole nother level.